You can see some of my background here. I've been programming for a long time. If you do the math, don't do it in front of me. But I've been doing since high school. And I program COBOL and some other strange languages, including some from the previous AI generation, Prolog and Lisp, which is interesting because some of them, Prolog is coming back again. And then as a consultant, you always, anybody always have to learn new languages. Flutter for mobile applications, Golang, Rust. And I even saw a kid in the train programming C, which not many people use anymore. But, you know, I programmed C 20 years ago. Anyway, so it's becoming more like a vibe engineering because there is a lot of techniques that are used by other branches of engineering. So, and you probably already heard about the perils of bytecoding before in the news, you know, deleting folders, all kinds of things. But there is a lot of promise, and I think that's where we should focus in developing the powers of bytecoding or vibe engineering. So even the original version was just like Google and generate scripting and stuff. But even the inventor of who minted the phrase bytecoding didn't like to do bytecoding. But it has evolved for a lot since that time, and we're going to go through that. There is some good habits of thinking. Any quick thinkers here? You? So don't have to worry about that. We're into good practices of thinking. And I was inspired by this guy, Andrew Stellman, who is pushing for critical thinking habits for coding with AI. But I think there is more to it than that. And we're going to see that, you know, critical thinking is about questioning and finding holes in arguments, finding fallacies, biases. It's pretty useful, but there is a little more for bytecoding. And I show you an example here. I work with a client that decided to take care of shift left, but by developing a tool named shift left. And I had some interpretations there. There is a fallacy called reification, which I love that word, misplaced concreteness, assuming that an abstract idea can be implemented as a concrete entity. But nobody thinks that way, right? So I thought there was another interpretation. So at the hammer, Maslow hammer, you have a hammer, everything starts looking like a nail, right? So this probably some executive thought, I have a great team of developers. I can solve anything. So let's solve shift left. And you know, that tool was a mess. I don't think they have it anymore. I forgot to check. But anyway, I had a chance to use it. You know, people could dump anything there, Visio diagrams and stuff. So it was hard to keep up to date. And especially because this company is a big corp, they had also Jira and Azure boards, you know, which should help a lot in doing shift left. So there is some best practices that can help. You know, I mentioned a few, but you know, it's still human in the loop. And as I say, things change. And one thing is that critical thinking is getting impacted. You know, it's because people are kind of like, well, okay, people get surprised when they ask me what's the most important skill for AI or for security, and I say critical thinking. Like, especially for AI, hey, we're developing AI, so we don't have to think too much. And that's where the fallacy of cognitive delegation comes. So we try to keep some cognitive integrity and also avoid cognitive debt. Because you generate something that was done by AI, so you end up really not knowing much what's the inner workings and all the details of the code or whatever you generate. So that's what that cognitive debt comes. Not to mention that you might end up also with security debt and technical debt. And so some people start paying attention to requirements, which they've been around for a while, especially by that organization in COSI, International Council of Systems Engineering. And they try to incorporate requirements in the processes. So some people came up with spec-driven coding. And the specs are requirements and tests from different processes. Any enterprise architects here, they emphasize when you do a certification on TOGAF, requirements are right there in front and center. So, but most other people ignore it. I had clients who tell me, hey, there is no time for requirements. We need some progress here. It's true, but I work with large corporations and telecom, they use a lot of requirements. And you work for the government, there is specifications and stuff, all kinds of stuff. So spec-driven development came up strong last year, at the end of last year, especially with GitHub. You can do that process at the bottom, specify, plan, then develop the tasks and implement. And GitHub will give you all those folders ready to use. However, it looks like a waterfall, right? You have this step without really looking back. So we're gonna, and then around the same time, AWS came out with Kiro. And the specs are right there, requirements, MDs, markdown files, design, and tasks, which you saw in the previous folders from GitHub. But there is also a couple of other files in the memory bank for steering the process. Product MD, technology MD, and a structure MD. So, say steering files and code projects conventions, so Kiro consistently follows established standards. And then, so there is a lot of enterprise-grade security here because, being in the AWS environment, you get built-in security, basically, with, VPCs and stuff. So how Kiro is still spec-driven development. So you use your specs files, which I mentioned on the left side in the previous slide. And then you have steering files, which they were there also. And then the AWS has a MCP where you can access like if it's a library or something, so the LLM doesn't have to come up with hallucinations or libraries that don't exist, which has happened, and so on. So this is the high-level process. Kiro uses an LLM, the foundation model for the process, and then generates the code and responses, and then becomes context for the next question or the next, the next requirement. So when to use bytecoding versus spec-driven development, because you can see that writing requirements and specifications and tests is a little more work than just the plain old bytecoding. So you have different aspects, and bytecoding can do something for you, but spec-driven can help even better because there is requirements in the process and structure files and so on that we listed in the previous diagram. So SDD has its own pitfalls, spec-driven development. There is some upfront overhead and time, initial effort, uncertainty, some cost fallacies. That's another fallacy of preferring to use some particular tooling over something that could be more efficient. And then there is a learning curve, and so on. Knowledge ossification, meaning that some of the old knowledge is not up to date with what's changing. And even the CTO from AWS in the previous reInvent conference said that the risks are not really hallucinations, but verification depth. Because as you saw, there is nothing, in the process, there is no really verification. In theory, you have test files, but it still need more verification than that, according to the specifications. Anyway, so how do we take care of that verification? That we resort to feedback loops, which has been used in DevOps for a while. Anybody read the DevOps handbook here? I think the diagram comes from the DevOps handbook. And I went to school with a guy, Gene Kim. So doesn't mean totally agree, but the feedback loops in this case are very useful. And in the development lifecycle, there is feedback loops all the time. In the farther down the road, even customer feedback and the deployment and reviews and so on. But so we leverage requirements traceability. If it's hard to find people doing requirements traceability is even more difficult to find in the field unless you work for the government. People in avionics have to do requirements traceability. So, but we can do it now because Jira even supports some of that too. And this is a high-level diagram of DevOps where you can do some of the traceability there. Along with shift left, you're also doing feedback loops, like scanning that fail and so on. Go back to the requirements and check them. So I mentioned Jenkins and Jira can help with this traceability. And there is already vendors that support the use of AI for that too. And it's called Aqua. Anyway, it's too much. It sounds like too much trouble, right? And I think the previous speaker was supporting this because he mentioned that the velocity in the front of development is much higher than the scanning. I need to borrow some of his numbers to plug them here. But anyway, so what happens is that the developer is generating code and then passing it to the outer loop, which is called there. But there is some hallucinations and bad output from AI. And when you get feedback from the scanner, the developer might have changed the code in a big way. So there is there could be a little mismatch. And that's why Anthropic is trying to cover the whole process, the whole life cycle. I haven't tried the whole thing because, there is manual reviews there also. And I think OpenAI is going one step further by creating a plugin to Anthropic code so they can plug into this part, and even the review don't approve it until the OpenAI tool approves it. So there is going to be a lot of interaction there, a lot of good. And actually, I've been doing this presentation every 2 months because things change so much. And I'm planning to do one in 2 months also, somewhere in Oakland. So stay tuned. But I like that competition that is coming. And then also, Databricks Gateway allows you to gateway the different code agents, so you can plug and play with whatever you want. But I like that plugin idea that OpenAI has done. And one more, I mentioned that critical thinking was not all. I like to include some lateral thinking also. You ever heard about that? That's basically thinking outside the box, which we all should do. And there is this guy, Ted Harrington, which I know in person, and his first book I read from cover to cover. And the second one is called Inner Hacker, which looks pretty good also. And it talks to some of these factors here. And he only covers 3, the first 3 over there, because he says he's talking to real hackers. I think they're ethical hackers, but because maybe in jail he could talk to real hackers. But anyway, so we'll cover those first 3 points there, and they come in that book. And although I changed the number 3 because he calls it break the rules. It's okay, but doesn't sound very ethical in my book. And rewrite the rules sounds more constructive. So anyway, so there's different points for lateral thinking. And I like the one, welcome serendipity, because I'm going to have an example there. But I'm going to go with challenge your assumptions. Sometimes they give you assumptions in the same folks who give you requirements or not. But you can always identify what assumptions are being made by reviewing what's been done and what the communications and so on. Some of them might be hidden assumptions and so on. So there should be a risk level associated to each assumption, and some of them can be obtained through doing some risk-centric modeling, like with Stride or with Pasta. I don't know if you hear those names. And this is a more detailed review of the assumptions that I ever done myself, but I like it, especially because it gives it more engineering flavor to the bytecoding. And asking provocative questions is also a good idea, Not really to ruffle feathers or anything, but just to get more details on what you are doing. And I suggest the process there, but you can develop your own way of doing provocative questions. All right, rewriting the rules. I put a puzzle here. sometimes the rules are unwritten rules. So you have to identify, what rules are there for you, and you know it because it's what guides you in your work or blocks your work. Anyway, I have this puzzle since I was in grad school. So I've been looking for a time to use it, and this is the right time. So I call it rewriting the rules, and the unlock pattern for lateral thinkers. The idea is to connect all these 9 dots by drawing only 4 straight consecutive lines. And this would be a good case for animation, but I'm using PDF, so so the trick, and that's where it is rewriting the rules, is to go from, one line, go all the way out, and then another line, touching these intermediate dots, and then go back to the original point. And that's 3 lines, and then just connect to this one, and that's 4 lines. That would be a more secure unlock pattern for my phone. So this is there is a bunch of puzzles for exercising lateral thinking. And I could bring more, but I guess that should be enough. Okay, it's time for a quiz here. The word serendipity was invented in the English language, as you can imagine. So many other cultures don't have that word. You try to translate it, directly. However, if you grew up in a Spanish-speaking culture, there is a fable that is becoming very popular. It's about a donkey that could play the flute. So the donkey was chewing the hair, and it happens there was a harmonica. A flute, it would be difficult, but actually in Spanish culture, they call the same word for flute and harmonica. So, any harmonica performers here? No? Yeah, me neither. So. Anyway, so all of a sudden the donkey finds itself with the harmonica in the mouth, and since he's exhaling and inhaling, the flute starts producing music. Music for a donkey, I guess. Huh? So the donkey say, "Oh, I can play the flute." All right, here's a quiz for you. Assume that the flute is AI. Who could be the donkey? All right, time up. That donkey could be NVIDIA, because NVIDIA was very happy showing graphics processors. All of a sudden, AI comes into his table, and he says, "All right, I'm an AI powerhouse, and $1 trillion, and his picture is in the wall of people outside there." And by himself, probably has made more money than the rest of the people there in the world. Anyway, so that's the reviewing of the diagram that I mentioned. Includes systems thinking for the big picture, the critical thinking for finding holes in an argument, and then the lateral thinking and vertical thinking for out of the box. And then you can use a lot more tools to do agents and stuff, and even open source, but it's not good for this community day. So when you want to use a coding agent, or when you want to just use regular vibe coding, you think in tasks, not code. That's when you start thinking about an agent. And then you want automation loops. coordination limits. Yeah, there is, they're in the diagram. I need to find a little more examples. And anyway, so the good thing is that other agents out there like Anthropic, because it's been a partner with Amazon for a long time, but OpenAI is coming also. You can integrate them into Amazon and use both or a combination. I'm not giving a demo because there is a lot of videos. And there is a superhero there too. Any questions? Maybe this one is more useful, but they're in the slides also in the agenda. What? Yeah, in the agenda. Is that true, right?